Welcome to all. I am Chayan Goswami. I have uploaded some videos for NEET and JEE, but these were very scattered and very few in numbers. So I have decided to upload videos regularly as possible, and these chapters will be based on NCERT, and the chapter will proceed also according to NCERT. Today we'll start with a relatively easy chapter, States of Matter. This chapter is one of the most easy chapter and it has nearly nothing to do with chemistry at all. So here we see two terms, states and matter. So first of all, we will define the terms. What is matter? We all know that matter is anything that has a certain mass and occupies a certain volume in space. Like you can consider a piece of brick. It will have some mass, obviously, and it will also occupy some volume in the space. Suppose V is the volume and M is the mass of that piece of brick. But here you can see that it has a specific dimension. Dimension is fixed. And if you change pressure or temperature, then the dimension will not alter very much. But if you take a cylinder of gas, then if you change the temperature, then the pressure of the gases inside the cylinder will vary. And if a piston is attached to the cylinder, then on changing pressure or temperature, the volume of the gas will also vary if we keep the mass fixed. So here we see that we have a substance with everything nearly fixed, but gas is also a state. Here we don't have everything fixed. So here we have the term state. How will we define it? So we can define state by giving values of some variable. You can think that here V, M, P, and T, all of them together for that brick gives the meaning of state for that brick. And here T, P, V, and M all together gives the meaning of state for this gas. So by means of state, we actually give a set of variables. Now, before beginning the chapter, how the state comes and how we will learn about the gaseous state in this chapter, we have to discuss about some forces, weak forces, weak forces, or Van der Waals forces. He was a Dutch scientist and worked on gases. And according to his name, the forces are termed as Van der Waals forces or weak forces. These forces are generally intermolecular forces. That is not between one molecule or atom, but between different molecules or atoms, these forces work. So first, let us see how many kinds of forces we will learn about in chemistry. In chemistry, we learn about strong chemical force, and weak chemical forces. In the heading of strong chemical force, we learn mainly ionic bond, and covalent bond. For ionic and covalent bond, we have a different chapter, but the weak forces are studies along with the states of matter. According to NCERT, we have three kinds of weak forces. One is dispersion force. One is dipole. Dipole interaction. And another is dipole induced dipole interaction. So we will start with the dispersion force, followed by dipole-dipole interaction, followed by dipole-induced dipole interaction. And the examples of those forces will be given. First, we start with first we start with instantaneous dipole-dipole interaction or dispersion force. Dispersion force or London force or instantaneous dipole interaction. For understanding this interaction, I will not go for the mere theory or any definition. Rather, I will go for an example that will help everyone better understood this topic. Suppose we have a helium atom. We know that helium atom is electrically neutral and it has no dipole. No dipole, neutral. So in anyhow, it may not have a dipole moment and it may not induce a dipole moment. But we know that anything do not exist in that pattern. It will have some resonance and the electron cloud above the nucleus will deviate. And what will happen? We will have an ionic structure or a polar structure for a very short time. And when that molecule becomes polar, it induces another helium atom to become polar. And that's how an interaction works between them. Here we see that the molecule or that the atom was completely non-polar and neutral. But due to resonance, it occupies some dipole or it consists some dipole, and due to that dipolar structure, it induces another neutral atom to become dipolar. And then those two dipole interact with one another, and this is an attractive interaction. And obviously, these attractive interaction will not last for a very large time. So this is a very short interaction, but due to this interaction, the molecule come close to each other. And we have the molecular volume less than that of expected, and also the pressure less than that of expected at a particular pressure, and in case of volume at a particular temperature. So we see that here non-polar molecules gain some dipole moment due to resonance, and then that dipolar interaction becomes an attractive interaction. So this is the London force. So this is a very weak force, and it varies with the 1 by r to the power 6, means to the 6th power of distance, to the inverse of the 6th power of distance. So we can say that here the force is very weak, and as soon as the distance increases, the force decreases in too much extent. Hence, we call it a weak force, or we study it under the section of the weak force.